In lesson 1.3, we're going to be looking at data collection and how to design experiments. There will be quite a few definitions, guidelines that you're given. I'm not going to read everything. You can read those for yourself. Some of the definitions I'll point out and explain them a little bit if it needs explanation. So the first thing we're looking at is designing a statistical study. And you can see the guidelines here of the things that you need to go through to design your study, decide what you're going to study, how you're collecting data, and then making interpretations. There are two types of study that we'll be looking at, statistical studies, and that is observational and experiment. In an observational study, the researcher is simply collecting data, making observations, recording measurements, recording counts, but the researcher is not doing anything to influence the study, not doing anything to influence the responses. In an experiment, the researcher deliberately applies a treatment or does something that affects the outcome. So this would be like if you were doing an experiment on plants and some plants got a certain amount of light and other plants got a different amount of light, you are doing something that affects the outcome. And within that, the group that receives the treatment is called the treatment group. And then you sometimes will use another group that doesn't receive any treatment, and that's called the control group. The control group may be given a placebo, which is a treatment that's fake but looks like the actual treatment. And we'll talk more about that later on in this lesson when we talk about the placebo effect and everything. So in our first example, all we're looking at is deciding whether it's a study or an experiment, an observational study or experiment. Question 1, the researcher studies the effect of vitamin D, the vitamin D3 supplementation among patients. To perform the study, the patients receive a dose of vitamin D3, and then another group of 70 patients receive a placebo. So since the researcher is giving the patients a treatment, this would be an experiment. And then on the second example, it says the researcher conducts a study to determine how confident Americans are in the economy. And all they do is call 3,040 adults and ask them to rate the economy as either getting better or worse. So all they're doing is asking a question. They're not applying any kind of treatment. So this is simply an observational study. So that's the first thing you need to be able to do is determine the difference between an experiment and an observational study. The next thing we're looking at is data collection. And all that's involved here, we have just a couple of definitions to explain how you can collect data, and then we'll move on. Simulation is the use of a mathematical or physical model to reproduce the conditions of a situation or process. So I'm sure you've heard of simulations before when they, for example, they do crash dummy tests on cars and things, and they simulate wrecks happening. They do things like that to see what might happen in a real case. So that's a simulation. A survey is where you're making an investigation simply by typically asking people questions. So you send out a survey or you call people up and you ask them questions, and that's a survey. So those are the two types of data collection you would normally see. Now, the majority of our lesson here is going to be spent on experimental design. And what we're looking at is how we design the experiment, what are some things we have to look for, some things we have to be cautious about, and how do we actually get our samples from a population? How do we pick who's going to be involved in a study? So a few definitions here very quickly. Again, you can read these yourself. A confounding variable is one that happens when you know that there is two different things happening, two different variables out there, but you can't really tell a difference. So maybe you apply 10 hours of daylight to one plant and you apply 6 hours of daylight to the other plant, and you really can't tell that there's any difference in the two. So that would be a confounding variable when the effects can't really be determined. The placebo effect I mentioned a minute ago is when you give patients a placebo, but they don't know that you're giving them a fake treatment and they react favorably to it. And this is just one of those strange things that happens sometimes. They're taking something, they think they're taking something that's going to help their headache, and it's actually just a sugar pill, and they react favorably to it and it helps their headache. So it's just a strange thing that actually has been proven to happen, and that's called the placebo effect. Blinding is a technique where the people that receive the treatments, and this is what you would do with the placebo, they don't know if they're getting the real treatment or the fake treatment. So they may be getting the sugar pill or they may be getting the actual pill that has a treatment in it, but they don't know. So they're blinded to whether or not they're getting the real treatment. And then in a double-blind experiment, the patients or the subjects don't know what they're getting, but the person that's actually conducting the experiment doesn't know either. The way you would do this is you would have a third party would come in and distribute the placebos and the actual treatments to the subjects without the researcher knowing who got what. And that way, when the researcher starts recording his or her observations, they're not going to know who got what treatment. And because of this is called a double-blind experiment. And this is actually the most preferred type of experiment because there can't be any kind of bias in it, since neither the experimenter or nor the subjects know who's got which treatment. Now, next we're going to be looking at what's called randomization, and that's just when you randomly assign subjects to different treatment groups. And there's several different types of randomization. One of them is completely randomized, where basically you just randomly pick people out and put them in there. You don't know anything about them. That's just completely randomized. Sometimes you will block subjects into groups. So, for example, you might have a group of male subjects and a group of female subjects, and they're blocked based on similar characteristics. And then you might want to give treatments based on that. So sometimes you'll block your subjects based on characteristics. Randomized block design is when you've got them divided into blocks, and then you're randomly going to pull out some of the people from each block to receive or to go into the treatment groups. So you divide them into blocks, and then you randomly select from within each block. And then the third thing here is, or the fourth one here, is matched pair design. And that's where you would pick two subjects that are paired up because they have a similarity. And then one subject is given us one treatment and the other subject's given a different treatment. Something you could think of here, let's say we want to test the effects of something on redheads. So you pick two redheads and you give one treatment and you give the other one a different treatment. So they're paired because they have similar characteristics, but then they're getting two different treatments to see what the effect of that treatment is. Okay, the last definition we have for right now is replication, and that's just the repetition of an experiment under the same or similar conditions. So you conduct the experiment once, and then you decide that you want to collect more data, so you go and you do the same experiment again, you replicate it. So on example 2, we are going to be looking at a company testing the effectiveness of a new gum developed to help people quit smoking. And they give us two different ways that the study was developed, and they want us to identify a potential problem and then suggest a way to improve it. So the first one is that the company identifies 10 adults who are heavy smokers. 5 are given the new gum, 5 are given the placebo. After 2 months, the subjects are evaluated, found that 5 subjects using the gum have quit smoking. The only problem that I would really see with this one is they only used 10 adults, and that's not very many to really decide whether or not it is effective. So for that reason, what you would say is the problem with this experimental design is that the sample size is too small. So you would just say the sample size is too small. So a way that you could improve the study would be to go back and replicate the study again, but use a larger sample. So we would replicate or do the same study again with a larger sample. The second scenario we have here is that the company identifies 1,000 adults, so we definitely have a larger sample, who are heavy smokers. The subjects are divided into blocks according to gender. Females given one gum, males given the placebo. And then they find after 2 months a significant number of the female subjects have quit smoking. The only problem with this one would be is that all of the gum or the actual treatment gum was given to females and all of the males got a placebo. So the only people who got treatment were females. So the problem would be is that you've got two groups that are not similar. So the groups are not similar. And what might happen is the females might react differently to the medicine or to the treatment than the males would. There could be something in it that causes it to react differently with the females. And so for that reason, what you could do to improve it is you should have given some women and some men the gum, and then some women and some men the placebo. And what happens here is because you're given the treatment to both male and female, and you're given the placebo to both male and female, you would then be able to determine if the gum works on everyone the same, both male and female, or if there is something in it that causes male and female to react differently to it. Okay, the next thing we're looking at is sampling techniques, and these are ways to actually find samples or create samples so that you can conduct your experiment. And when we're looking at this, again, we have several definitions, and I'll go through some of these rather quickly. You can go back and read them better yourself, but most of these are pretty self-explanatory. The first one is a census, and a census is a count of the entire population. This is something that is not done that very often unless you have a small population you're looking at. If you were looking at a, let's say, a small university that only had a couple of hundred students, then you could probably conduct a survey or an experiment with the entire population. But for the most part, we don't typically do a census because our populations are usually too large. An example of a census is when the United States every 10 years sends out surveys to everyone in the population, or as much as possible, to figure out the number of the population, and they also ask questions that determine education level and household income and all of that. So that's done to try to decide how many people are actually living in the United States, within each state, within each town, and everything. So that's something that's usually a little more difficult to do because the populations are so large. So what we typically do is we typically use a sampling, and a sampling is when we just survey or do a treatment on part of the population, and that's what's very typical. If you have a large university, it's may not be possible to survey every student, but you may pick some students and do the survey and then make a determination for the whole population based on that survey of that sample group. A sampling error is what happens when you look at the difference between the results of the sample and the results of the population. So if you were to actually survey the entire population, what conclusions did you draw? And then what happened if you only surveyed half the population? There's usually going to be a difference between the results because you didn't survey everybody in the sample. So that's what a sampling error is. A random sample is one in which every member of the population has an equal chance of getting selected. So anybody on the university campus could be selected at random. And then a simple random sample is a sample in which every possible sample of the same size has the same chance of being selected. And we'll talk about that, I think, in one of the examples. So the first thing we want to do is, how do you create a random sample? And we talk about two ways here. One is to use a random number table to create it, and then another way is to use a graphing calculator. And we'll start with the table. We have 731 students enrolled in a statistics course, and you want to form a sample of 8 students to answer some survey questions. So you want to randomly pick 8 students out of the 731. So what you're going to do is you're going to assign 1 through 731 to the students. So you could do, and you could assign that any way you wanted to. It could be alphabetically, just start with go alphabetical order 1, 2, 3, 4, 5. But you're going to assign the numbers to the students 1 through 731. And then what you're going to do is you're going to just pick a random place on the table to start. It does not matter where you start. I'm going to start right here on this row at the 71966. I'm going to start right there. So this is going to be my starting place right here. And what you're going to do, because it goes up to 731, we need to be able to go up to 3-digit numbers. And so what I'm going to do is I'm going to count 3 numbers and draw a barrier there, or a dividing line. And then I'm going to count 3 more numbers and draw a line. 3 more numbers and draw a line. And we're just going to do that as we go across. And when we get finished, we want to make sure we have at least 8 numbers. So 1, 2, 3, 4, 5, 6, 7, 8. So we've got plenty. So then what you're going to do is you're going to write down those 3-digit numbers. So we have 719, and then 662, and then 738, 650, 004. So you could just put 4 there. 053 would just be 53, 589. 403, 129, and so forth. And we want 8 of those. The only thing you have to check is, remember, we're only going to 731. So if any of your random numbers you have are more than 731, you would need to discard those. So I'm going to discard the 738. So I have 1, 2, 3, 4, 5, 6, 7, 8 numbers, and that would be my random numbers that I would pick from the students. On the graphing calculator, in some of the later lessons, when there's quite a bit of graphing calculator work, I will create a different video that has the calculator displayed, and I will show you how to do the calculations on the calculator. But this one's pretty self-explanatory. What you're going to do is if you're using the TI-84, remember that's the calculator I told you I would be using. And if you're using the TI-84 calculator, you're going to push the math button. And then from math, you're going to select probability, and then you're going to push 5 for random integer. And then what you're putting in here is the smallest we want to use is 1, the largest number is 731, and we want to pick 8 numbers. And when you push enter, the calculator will just randomly give you 8 numbers between 1 and 731. And if you did it again, it would give you a different set of 8 numbers. That's why it's called a random number generator. Okay, the last thing we're going to look at here are a couple of other ways to get a sample, or actually, I guess 4 different ways. We have stratified sample, cluster, systematic, and convenience. I'm not going to read the definition to you word for word. I'm going to use the illustrations here to explain it. So in a stratified sample, what you do is you divide up samples from the population. So what you're going to do is you're going to divide them up into similar groups of similar characteristics. So the example they give here was that we have low-income households, middle income, and high income. So we've divided these up according to similar characteristics. We have our low income, middle income, and high income. And each one of these is called a strata. So we have 3 strata here. We've got 2 or more subsets called strata. And then what you're going to do in a stratified sample is you're going to randomly select samples from each of the strata. So from the low income group, you're going to need to select, 2 or 3 households out of that to be included in the study. From the middle income, you're going to need to select 2 or 3, and from the high income. So what happens is we have 3 different groups of people, and then we're choosing 2 or 3 people from each of those groups, and that's called a stratified sample. A cluster sample happens when the population's already naturally divided. The example they used here was zip codes. So if you had in this county, there are 5 or 4 different zip code, and everybody that lives in zone 1 has the same zip code, and everybody that lives in zone 2 has the same zip code. And then what you're going to do after you've got those into those clusters, they're called, once you're divided into the clusters, then you're going to take all the members of that cluster, and that's going to be part of your sample. That's going to be one of your samples you use. Now, notice here it says that you're going to select all members in one or more clusters, but not all of the clusters. So if you did all of the clusters, that would be the whole population of the county. So that wouldn't be a sample, that would be a population. So what you're going to do is you're going just to select 2 or 3 of the clusters, and those would be included. The next one is a systematic sample, and this happens when you systematically pick. The example they used here was they numbered the households. So we have 85, 86, 87, and so forth, and they numbered them, and then they just picked a random starting point. So they said, okay, we're going to start at house number 86, and then we're going to choose every 100 after that, every 100th household. So we're going to use 86, 186, 286, 386, 486. So what you could do here is you could go in and say, okay, I'm going to stand outside the library, and every third person that comes out, I'm going to hand them a survey, and that would be a systematic sample. And then the last one is the convenience sample, and it's called a convenience sample because you're only surveying or including people that are easy to get to. So like if you were sitting in your math class and you only ask people in your math class a question about the university, that would be a convenience sample. The only problem with convenience sample is they're often biased because you're asking a group of people who are all in the same situation at the same time. So you may not be really be getting the ideas or the responses that would reflect the entire population. Another example of that would be if you sit in Starbucks and you ask people that come into Starbucks how they feel about Starbucks. Well, obviously, if they're coming into Starbucks, that probably means they like Starbucks. So you're getting a biased opinion because you're surveying only the people who are in that store at that time. Okay, so our fourth example, and this is our last one, is we want to identify what kind of sampling technique was used, and then, of course, discuss if there's any source of bias. So the first one is you divide the students with respect to majors, and then you randomly select and question students from each major. So when we divide them with respect to majors. We are creating groups of similar people. So the math majors, the science majors, the art majors, we're creating groups of similar people, and then we're randomly selecting from each of those groups. So since they're divided that way, we said that when we do that, we're dividing them into strata. So this would actually be a stratified sample. They're divided into groups with similar characteristics. That's a stratified sample. And really, there wouldn't be any potential bias here because you're getting pulling random people from different groups. So there shouldn't be any bias. Number 2, you assign each student a number and generate random numbers, and then you question each student whose number is randomly selected. So every student was assigned a number, and then you're randomly selecting every number, so any person has an equally likely chance of being selected. So this would be a simple random sample. And again, this should not be biased because you as long as you get a large enough sample size, you're randomly selecting people, so there shouldn't be any bias. And then the last one, you select students who are in your biology class. So if they're in your biology class, you have easy access to them. So this is definitely a convenience sample. And the problem with a convenience sample is, remember that all those people may have similar characteristics, and you may not be getting the getting ideas from the population as a whole. So the problem with this particular one was, if you go back and you read the what the study was about, you're doing a research to determine the opinions of students at your school regarding stem cell research. And so the problem is, if you're in a biology class, those students probably know more about stem cell research than the general population at the university would. And because of that, they may have different opinions than someone who doesn't know anything about about stem cell research. So this would be maybe biased because biology students may be more familiar with stem cell research. So therefore, that might affect their answers. And that concludes this lesson.